So today we are going to be analyzing doing the qualitative analysis of this year's chemistry practical, alternative B. So if you are preparing for this exam, I want you to pay attention, get your pen and paper and pay attention and watch out and watch as I do all the experiments, all the tests for you, and I will want to encourage you to pay attention because all the tests I'm going to show you here, at least you're likely to see 4 or 5 of them, just like the alternative A. What I analyzed, the test I carried out, at least 4 of the tests appeared. So I want you to pay attention and watch as we get along. From here, I have just a model question of the test that I'm going to be going through here as I show you whatever we are doing. Here it said that F is a mixture of copper 2 tetraoxosulphate 6 and starch. That's exactly what you're going to see. But what you're going to see in that is F. They will write F. Just for the purpose of the class that I have to give you these salts. So these are the salts. This is the salts, and then these are the organic compound that is involved in the test. So here, the first test this is a mixture. Since it's a mixture, the first thing you are going to do there is to what? Separate them, because it's easier to work with them when they are separated. So the first one said that F plus distilled water, filter, keep the residue, and divide the filtrate into 5 portions. Actually, I have already done the filtration, but then the residue is here with me. What I will do now is, and the filtrate is also in this filter paper. The residue is in this filter paper that I have with me. And then what I will do now is to divide into 5 portions. Let me quickly do that. I'm going to divide into 5 portions. 1, 2, 3, 4, and finally 5. So we keep our residue too. So now it's not necessarily in the exam that you're going to be dividing into 5 portions, just like in the alternative B. I did about 4 or this, either 4 or 5, I can't remember, either 4 or either 5 too. I did that, and it happened that they did not really carry that all the tests. They stopped at somewhere along the line. But today I'm going to be doing this. As we are doing this, I want you to pay attention. Now I have done the division. Now what do I really observe? I have a white residue, and what we have here is colored filtrates, colored preferred. That's more like a blue color, light blue color. As you can see, it's a light blue color filtrate. I think I can use my color. You can see that it's light blue color. So what I'm going to do in writing our observation. Our observation is what we have here is what? Partially F is what? Partially soluble. What again? The residue, we have what? White residue and light or pale. Let me use pale blue filtrates. So what do we have here? What should be going in here in the inference? That means it's a mixture of soluble and insoluble compound, insoluble compound. Having pale blue color could mean that transition ion likely present. Remember, colored ion is one of the characteristics of transition elements. So by having a color, meaning that we are likely to have what? Transition ion in it. So the next one, so that the first portion of our filtrate. So you say we should add to the first portion, add zinc dust. So we are giving zinc dust according to what we have there in the paper. So I'm getting the zinc dust, then I add small portion of it inside it. I just added the zinc dust into it. Now I notice something. Yeah, that's good. Interesting. The blue color, light blue color has gone out, and we have brownish. We have a precipitate there that look brownish. You can see that still the precipitate we have that is looking brownish there. I believe that when the thing will settle, we will notice everything clearly. I will still call back to it. So you see that the blue color has gone out. So what does it entails? From our observation, what we have here will then be, what we have here will be, from our observation, we say that light pale blue color disappear. And then what again do I have? And then I have that's somewhat brownish. Brownish precipitate. Formed. So what do we have here? What does it mean? What it means here, what will be in this case means that since we know it's zinc and then we don't know what we have there, simply means that the zinc, that's a displacement reaction. Zinc displaced the metallic ion in the solution. So that is what we have here, because that's exactly what the inference is telling us, that it's a displacement reaction that is taking place. So the next one we'll go over now. So to the next portion, add dilute sodium hydroxide. We have our next portion. We're going to add dilute sodium hydroxide. Excuse me. Okay, we'll add dilute sodium hydroxide in drops, and then in excess, the sodium hydroxide we'll add in drops. Let me see if I will make it in drops. Now we have in drops, we have a precipitate, blue gelatinous precipitate. We have blue gelatinous precipitate here, blue, gelatinous precipitates, then let's say we add an SS. It's always nice to reduce the quantity and then use small quantity so that you'll be able to get the best results. So at least you have small to make it easier for us to know when we're adding an SS. So I add now in SS. You can see the precipitate is insoluble. It's still insoluble. That is to say, insoluble in SS. Insoluble in SS, as you can see, is insoluble with this SS. So what do we have here? What we have here will then be copper 2 ion, likely present. Copper 2 ion likely present, because copper 2 ion is the ion that can give this kind of test. So we'll go back to the next one. So to the another portion, add aqueous ammonia in drops, then in SS. Then we have another portion here. Another portion of that. This is another portion. We add aqueous ammonia. Aqueous ammonia. Now I see that we already have it in SS here. Okay, it seems that we already added in SS because of these two different colors. We have how many colors here? Now, I want to explain something that happened here. It's like I mistakenly added in SS. I want to explain what happened here. Here is the region of SS sodium aqueous ammonia. Here is where we have unlimited sodium aqueous ammonia. This is where we have, that's why we have the pale blue gelatinous precipitate there. Here where we have SS is where we have the deep blue color, which is normally the case when we add in SS. If we add in SS now, but this that area, this is what I would have gotten if I had managed to put few drops. I did not use dropper in this case. That's just why it's so. So I want you to know this. So what we have here is that the region of limited aqueous ammonia, we have what? Pale blue precipitates, gelatinous precipitates there. So we can say there is what? Pale blue gelatinous precipitates. Then let's see if we can mix these ones up and see if we can get the actual thing now. Don't need to add another one because it's already in SS up. So in essence, this is likely what we're going to get. So because I've succeeded in shaking it so that all of them will mix. So when you're adding your own in your hall, in your exam, make sure you are careful about it. So this is when in the synthesis you have a deep blue solution, which confirms the presence of copper ion. And then we say soluble in SS to give a deep blue solution. That's what we have. Deep blue solution to give us deep blue solution. As you can see here, it's a deep blue solution that we have. So what is telling us here that it's telling us that what we have here is what? Copper. In the inference, you have so we have copper 2 ion. That's copper 2 ion confirmed. Confirmed. That is what we have here. Copper 2 ion is now confirmed. So the next one we're going to be doing now, we're going to carry out the next test we're going to be doing. So now the next one we're doing is what? To the fourth portion, add lead 2-triazo-nitrate 5, then dilute nitrate 5 acid. So what am I doing here? No solution here. I did not make this solution early enough. I forgot this one actually. So the fourth portion, I'm adding I was supposed to make this solution early enough, I did not. I left it there like that. Add the lead 2-triazo-nitrate 5. So on adding, what we have is what? White precipitate. On our observation, what we observe is what? White precipitate. This white precipitate say that we add or dilute nitrate 5 acid. Then our dilute nitrate 5 acid I add. I should reduce this volume. I add to it. You notice that precipitate remains. On addition of this, the precipitate still remains there. So what is telling us now is that we have a white precipitate which is insoluble in dilute triazonitrate 5 acid. So what are we going to have in our observation? Our observation will be what? White precipitates insoluble in dilute nitrate 5 acid. So it's insoluble in that. So what will be our inference? Our inference will then be for this white precipitate, for the fact that we have white precipitate, it could be triazo carbonate 4 ion, could also be triazosulphate 4 ion, or tetraoxosulphate 6 ion likely present. because of this white precipitate, and insoluble in dilute nitrate 5 acid, meaning that these other ones are absent. Tricarbonates, triazosulfate 4 ion absent. Then what we have here could be likely what present. That is what we have here should be tetraoxosulphate 6 ion likely what present. So we'll go to the last one. So the last portion say we should add barium chloride. This is barium chloride solution. Barium chloride solution. So the last portion we add what barium chloride solution. So I'm adding barium chloride solution here. We have white precipitate again. So we have white precipitate, and then this white precipitate we have with also white precipitate. White precipitate. So it means that because it's white precipitate, it means also the same thing. Triazosulfate 4 ion, triazocarbonate 4 ion, and tetraoxosulphate 6 ion likely present. So let's see what will happen. The next one says that then dilute hydrochloric acid. Dilute hydrochloric acid. We add dilute hydrochloric acid to it. So let's see what we will get. Dilute hydrochloric acid. The precipitate is still insoluble. For the fact that precipitate is insoluble, what we mean that insoluble in dilute HCl, meaning that tetraoxosulphate 6 ion confirms. Tetraoxosulphate 6 ion confirmed. That is what we have here. Is then confirmed because why is it confirmed? Because barium chloride of tetraoxosulphate, barium tetraoxosulphate 6 salt is insoluble in the acid. If we have triazocarbonate or triazosulphate 4 salts or ion there, they will be soluble, making this one absent. That's tetraoxosulphate 6 ion absent. So now the last one, say to the residue, few drops of iodine solution. To the residue, I'm going to add few drops of iodine solution. So I have my drops of iodine. So let me put it here. We have so what we have here, you can see it now. We have a blue-black correlation. That's a in fact, this is more like black only. You can see the color of the residue. That means it's only starch that can give us this kind of test. So what we have here, in addition, we have a blue black color formed. So what we have here is what? Starch. Confirmed. So that is the last experiment here. If you are able to get to this point, thank you so much for getting this far. And there are other exciting video clips that you can watch in this channel. And then we want to encourage you to subscribe if you have not subscribed to our channel. And then there are other things where we're going to be doing the volumetric analysis, which is redox reaction. That's a mind-blowing experiment that you will not miss. Thank you for being part of this class. And remember to leave your comments and then share so that the video can get to other people. Thank you so much.